वो
हेलो हेलो, एम आई ऑडिबल?
अनम्यूट करो। हेलो, हाँ आ रही है, आपकी आवाज आ रही है।
ओके सर, गुड मॉर्निंग।
वेरी गुड मॉर्निंग टू यू सर।
Yes. So, Professor Pitamji, you are present here?
Yeah. I am introducing Professor Pitam.
Okay.
Good morning, everyone.
Recording in progress.
It's my honor to introduce today's esteemed speaker, Professor Pitam Singh, who is currently the professor and head of Department of Mathematics at Motilal Nehru National Institute of Technology, MNIT, Prayagraj, Uttar Pradesh. Professor Singh holds a PhD, MPhil and MSc in Mathematics from NIT Allahabad and has over 21 years of teaching and research experience. His expertise lies in fuzzy multi-objective optimization and its applications in GIS and remote sensing. Throughout his impressive career, he has published over 50 research articles in leading international journals and contributing significant advancement in the field of operations research. Professor Singh has also guided 7 PhD theses and 22 MTech theses, and he has supervised various MSc projects with more ongoing under his mentorship. Professor Singh has led two major research projects. The first was sponsored by DST SERV on the topic of sum of fractional multi-objective programming problems. And another was funded by ICSSR MHRD focused on social priority based urban road transportation system by using GIS and DA. His academic excellence has been recognized through several accolades, including being honored in Orson 2014 by the United Group of Institutions for his distinguished services academia. In today's session, Professor Singh will be sharing his insights on generalization of fuzzy sets, extension of fuzzy sets, and their applications in real life problem. A topic that promises to offer valuable perspectives on advancing fuzzy logic. So please join me in welcoming Professor Peetam. And I welcome you, sir, and I am very much honored to invite you as a speaker in our workshop. And I am sure that this will surely benefit the students, and the students will get get in enriching their knowledge in the fuzzy logic and their applications in real life. Welcome you, sir.
Thank you, sir. Okay. Am I audible now?
Yes, sir.
Okay. My screen, is it visible?
Yes, sir.
Ah, okay. So today I am going to present that is the generalization, application of generalization, generalized fuzzy sets and optimization. So that is first in first few slide I will just introduce some parts of that is the numbers, fuzzy numbers and how to construct and how its arithmetics. So that is the first of all, what is fuzzy sets? Everyone knows. In the first lecture I explained this, and numbers also. So I skip this part. So first of all, triangular fuzzy numbers, various kind of fuzzy numbers are used in the generalization parts of fuzzy numbers. So this is the basic, very basic, the triangular fuzzy numbers. So it is the basic, it is this figure, triangular. This is the support of that part. If we want to express in real life problem also, suppose we want to express any color combinations. Suppose we want to express black. So there are various shades of black or any kind of colors. So black, gray, and like that, very black, very much black, or we can explain terminology in a linguistic way. So we have, this is the highest. So we can construct the membership function for every type of membership function. First we construct for this part, and second one we construct for this part. So this outside, and so this one for this otherwise, or this for this part, left part, x1 minus a1, a2 minus a1, when lies a1 and x lies between a1 and a2 for any argument. For less than, this value is 0 here, and for this, so we can construct this membership function for this triangle. So that's why it is known as triangular fuzzy numbers. So we are representing the uncertainty, data uncertainty in triangular type. So that's why it is known as triangular fuzzy numbers. Similarly, so we have arithmetics operations on triangular fuzzy numbers. We can take two fuzzy numbers a and b. Always it represents through triplet fuzzy numbers. Then addition, subtraction, multiplications, divisions, and accuracy of triangular. It means ranking. How to defuzzify, how to find its average membership for this. So that is its and decision making. So that is the defuzzification of its crisp value. We can define through this. So a1, a2 are the arguments which are based on, and their membership functions according to that triangle. Similarly, if we take the figure, the trapezoidal type, it means some flat is there. That's why it is known as trapezoidal fuzzy numbers. And how to construct? So first for this part, second for this part, and in middle part of this. So that's why membership function for between a2 and a3 is 1. That's why we have taken 1, and we can construct this for this part, x minus x, by taking any x between here a2 and this. So that's a2 divided by a2 minus a1. So x minus a1. This x minus a1. So this is, if we take this, so that distance divided by whole, so it is less than 1 always. So similarly for this part, and so that's why we have constructed this trapezoidal. And again we have its fundamental operations, addition, subtraction, multiplications for two numbers. Then we can calculate division, multiplication, subtraction, addition, everything here. Similarly, suppose we about two types of numbers are linear type numbers which are easy to operate in any application. But in the real world applications, always we don't have the clear linear equations, linear line. So that's why we have taken the non-linear functions here, but it is also this, so represented by this for tuples type. So it is the LR fuzzy number. It is the equation for this curve. This is the maybe quadratic type. Some flat is there and some. So always this is monotonically increasing in any numbers. This is monotonically decreasing part. So in LR fuzzy numbers, this name we named this as the left spread and this is right spread in this. So that's why this equation may be quadratic, any kind of curve here, and this is also any kind of curve and lies between here to here, x lies between here and x lies between here to here. But this is A1 here, the counts from here to this alpha A1, this point is A1 minus alpha, this A2 plus beta, this is A2 from here to here, 0 to origin to here, A2 plus beta. Then we can construct this. So it is very easy to construct membership functions or any kind of numbers. It's arithmetic operations for this type of LR fuzzy numbers. We can take A and B to LR fuzzy numbers. Then arithmetic operations defined as like addition, subtraction, multiplications, division. So we can use this. These are the operations. The fundamental I earlier explained this. So now if we take the uncertainty, the Gaussian type of curve, so we can define this Gaussian type of the Gaussian curve as usual. So we have in the Gaussian type of curve, we have bell shape. It is bell shaped. So we consider here in place of that left spread and right spread. In any general fuzzy numbers, we can take Gaussian fuzzy numbers, left spread, but left spread and right spread always in Gaussian, it is the standard deviation. So we can consider standard deviation as left spread and right spread, and we can define this e to the power this, the Gaussian curve from here to for this part, and this is for this part. So this is the Gaussian representation, simple. We can use Gaussian function as a membership function for the Gaussian type of fuzzy numbers, and we can represent this if we know the symmetric or standard deviation is here for this as a normal curve. And its arithmetic operations are very simple. If we consider two numbers with standard deviation, two Gaussian fuzzy numbers with standard deviation sigma 1 and another Gaussian fuzzy numbers with sigma 2 Gaussian fuzzy numbers, then arithmetic operations defined as this addition, subtraction, multiplication and division. It is very simple. Addition of two fuzzy numbers, subtraction of two fuzzy numbers, multiplications, division. So we can consider the fundamentals as Gaussian. If we consider the quadratic curve, both are the quadratic curves. So quadratic curve can be for this part, left part. This is the right part. This is the model value around which we are taking the uncertainty. If we want to consider the color determination or any decision making problem, that is suppose So that's black. So for black, clear black, it is membership grade is 1. For different, the more black, low black, and higher black, like that, we can consider the any kind of linguistic representation for any statement. So that's the membership function can be defined as, it means it is simple that distance x is here x minus al and divided by a minus al. That's it is same as, so al square x minus a, it is quadratic, so 1 minus this. So for this quadratic part, similarly for this, the right part of this, like a parabola representation. So we can consider this equation for this and this. Arithmetic operation. So that's. Am I audible? Voice is clear? Hello.
Yes, sir, but screen is not
This is clear, but your presentation is not on the screen.
So that's the arithmetic operations.
Your screen is not visible.
Okay. Screen is not visible.
You can share the screen again.
Yes. Hello. I think I'm able to share this.
Now,
Allow me to share the screen.
you are co-host, so you can share.
Okay. Share this. The sharing screen button is disabled through this. Share one participant can
You can
share.
join. You can join again. Disconnect करके again. You can join that. Then it will again.
Yeah, I will.
आप ना एक बार डिस्कनेक्ट हो जाओ और दोबारा ज्वाइन करो, फिर आप कर पाएंगे शायद.
recorded.
Now this.
Visible, visible.
Okay, okay, okay.
Please view slide mode.
Okay.
Okay, now it's okay.
So that's why we can consider various types of numbers and we can use to construct generalized Fuzzy numbers, these numbers. Now I come to that's the main part of my talk. That is the generalization of Fuzzy numbers, how to generalize. So suppose here uh, first generalization is intuitionistic fuzzy sets. So that the main important part of generalization and main motive of generalization of fuzzy sets is, so here the in the previous kind of numbers, triangular, trapezoidal, and various types of numbers were there, but there we have considered only the membership grade of any particular linguistic terms in decision making. The membership grade only, but here generalization. But as we know, the in the fuzzy set theory, the boundaries are not sharp, so they are unsharp. So we have considered in the only the membership grade to define any fuzzy numbers or fuzzy set only. So that's why we have the generalization with the help of membership function, membership grade, and non-membership grade. And that's for the membership grade. For example, suppose in some type of in the survey of data of elections also in nowadays it is going on, the survey reports and election predictions and everything predictions on data in machine learning. We have uh, we will work on the data only, on data science or machine learning algorithms and AI, all that. So we have considered that's some of them in favor or some of is non-favor, and but the favorism we can, it is uncertain, and non-favorism it is also uncertain, and some of the persons are neutral. So that neutrality we can consider in generalization of fuzzy sets. So that is the some in decision making problems also. We are uh, we are uncertain. We have the hesitancy to express our views. So that's why we have considered the hesitancy also in this generalization. So we have three parts: the membership function, membership, non-membership, and hesitancy corresponding to for any statement of. So that's suppose we have considered S be a universal set. So in these fuzzy sets, set in A, fuzzy set A in S is a set of the form. So, we are considering the representation for corresponding eta. Eta is the argument or any statement or which is the belongs to support. So that is the membership value for membership grade for that eta, particular eta, and this is the non-membership grades here. So that's 0 to 1. It should be a value which is known as the degree. So that is pi a.
Hello, Professor Petam, the screen is not visible now. Professor Petam, do you hear me? Hello, screen. आवाज तो एकदम से अभी डिस्कनेक्ट हो गया है आपका, उससे पहले आवाज भी चली गई थी, थोड़ा सा पहले वो डिस्कनेक्शन की वजह से ही गई होगी। तो आप कनेक्ट हो जाइए जी। So the expert Professor Petam is shortly connecting again. There is some network issue due to which the discontinuity we are facing.
वीडियो तो नहीं है, उधर की होना ना।
Yes, now your screen is visible. Professor Petam, do you hear me?
Professor Petam, please unmute yourself.
आप ठीक है सर?
Yeah, it's okay.
The screen is visible now. You can continue.
बता दिए करो थोड़ा
Yeah,
सा।
yeah, it's fine.
क्योंकि फुल स्क्रीन में पता नहीं चलता ना।
नहीं, अभी अभी हुआ है विजिबल, इससे पहले हुआ था फिर चला गया था स्क्रीन।
ठीक ठीक।
अब विजिबल है, now you can continue.
Okay, okay. So that's for intuitionistic fuzzy sets. We can consider it means membership, non-membership, and hesitancy. So hesitancy can be calculated through this formula. So intuitionistic fuzzy numbers can also be defined like any kind of fuzzy numbers. So here we consider fuzzy numbers and for membership value as well as for non-membership value and hesitancy also. So for triangular fuzzy number, for the generalizations, we can define the intuitionistic fuzzy numbers with any kind of, that is the triangular, trapezoidal, exponential intuitionistic, quadratic intuitionistic, or any shape which you want to describe or do the research on this, and it is depends on the uncertainty which you can define. So that's the suppose the intuitionistic fuzzy numbers, number A is defined as the tuples like that. This is the number for non-membership data. This is the number for this is for membership. This is for non-membership, and for there are two membership grade, mu A, this mu AX for membership grade. This is for non-membership grade. So this is the membership functions for the that number. So and we can consider the that ranking and accuracy defined for ordering the general fuzzy numbers, any kind of general fuzzy numbers, and ranking is defined for the defuzzification part. For the given triangular fuzzy number, suppose this, the ranking, it is the score function. Score function. So is it okay?
हाँ हेलो अभी क्लास नहीं है
आवाज आ रही है ना सर?
Yes, sir. Audible.
You are audible.
Okay. So that's the accuracy. That is the score function. It is for just ranking. Here the name is score function. It is the ranking function, and we can define for this as a. And this is the accuracy function. It is also used for ordering. So that's these are the some conditions. Triangular intuitive is preferred. It is for neutral. It is for less preferred. For any kind of we can define for this fuzzy number. So A is higher. Value indicates more accuracy, less hesitation, and while lower HA suggests more uncertainty and or agitation. This is used for characterizations. Uncertainty is there, how much uncertainty is there. This is for only for this arithmetic operation. So we have fuzzy sets numbers, or we have the same kind of operations, sum of numbers, fuzzy sets, and for membership, non-membership, for subtraction, multiplication, division, do the powers, a positive, negative multiplication of by scalar, like that. So score and accuracy. Score can be in fuzzy set theory. We can define these two only in the fuzzy sets. Intuitionistic fuzzy sets. So for two fuzzy sets, we can see just for by using the by ordering numbers, by ordering the fuzzy sets, which one is better, bigger one, like that, as a subset of this. So that's score and accuracy we can define in fuzzy set theory. Basically, this is the graphical representation of this intuitionistic fuzzy sets. So we have considered here this for membership, and this for this triangular for non-membership. So this is the representation of this. So we have to this for non-membership, P for membership, P part, That's P1, P1, that's P1. We have defined this for P2 and this for this this part. So that's it is also defined as. So this is a graphical representation, and similar way, in the similar manner, we can generalize that intuitionistic fuzzy sets as Pythagorean fuzzy sets. Pythagorean, it means the same as same, and for intuitionistic also we can define triangular intuitionistic fuzzy numbers, trapezoidal intuitionistic fuzzy numbers. If we consider trapezoidal type of uncertainty, if we consider quadratic, then quadratic intuitionistic fuzzy numbers, like that, we can consider this. The Pythagorean, it means it is nothing but it is the same membership, non-membership, and hesitancy. But here the we are considering this is the square part. This square sum of the squares of membership and non-membership. It is lying between 0 and 1 here. And hesitancy can be defined as square root of this. It is the degree of hesitancy, and the degree of hesitancy shows how much uncertain we are here. And the arithmetic operations for this suppose two sets here, we are considering fuzzy sets, Pythagorean fuzzy sets. At the same manner, we can define the Pythagorean fuzzy numbers. It is same as like intuitionistic. We can consider one number for it is for membership, it is belongingness, it is non-belongingness. The one triangular number for non-belongingness and one triangular number for belongingness for any arguments. This any argument. We can consider this the arithmetic operations for these sets and numbers. We have the various considerations for numbers, sum, multiplications, and like that. So this is the all about Pythagorean fuzzy sets. At the same, we can consider arithmetic operations, subtraction, division, like that. The same kind of number theory, numbers, the systematic arithmetic operations on numbers, Pythagorean, triangular fuzzy numbers, like that. And score functions can be defined for fuzzy. This is for only the fuzzy sets. And we can develop the numbers, the rankings, ranking, so that intuitionistic, I want to say this about. So this is the average ranking. It is the sum of average of this part for this membership, and of this triangular we want to find the intervals up to here and here and average of that, then we get this intuitionistic score function for this. Here we have numbers, numbers is here, score functions in numbers, this one. We get this. So like triangular, as you know, this is the part for this minus this. So hesitancy इसमें हम कर सकते. So Pythagorean fuzzy numbers. Now we have Fermitian. Fermitian, it is nothing. It is just some extension of its intuitionistic, Pythagorean, and Fermitian. Here same as we can define the uncertainty in Fermitian type if we have the cubic sum less than 1 for membership and non-membership. So define and Fermitian fuzzy sets is here membership degree, non-membership degree, and we can find the hesitancy here. So membership, non-membership, and hesitancy. And through this, we have arithmetic operations on fuzzy set, Hermitian fuzzy sets. It is simple as like this for on membership, non-membership, for any arguments of this, and subtraction, division, like that, and score and accuracy. This is for ordering of fuzzy sets, not the number. And for numbers, we have to define the score function for defuzzification, accuracy for for the ordering of fuzzy numbers. So this is the graphical difference between the comparison of intuitionistic fuzzy numbers, or that's intuitionistic fuzzy numbers or fuzzy sets, and this Hermitian and Pythagorean. So this is for intuitionistic, this is for quadratic for this membership for Pythagorean, and this is for Hermitian. So we have more flexibility in Hermitian, and we have more flexibility than the intuitionistic in Pythagorean. So we can compare like that. So we have now we can extend one another version of generalization of fuzzy numbers. It is known as the neutrosophic set. Neutrosophic set, that is the neutrosophic set, we can define this single value neutrosophic set. It is here in neutrosophic we have truth, that is the truth, degree of truth, degree of indeterminacy, where we have agitation, and degree of falsity. The term is here for membership and non-membership, and hesitancy is like that. The degree of truth, degree of indeterminacy, where we can't decide, we are not able to take the decision. So we define the indeterminacy, and f and x, here it is the falsity membership function respectively. And this satisfy, it is the sum of membership, degree of truth, degree of indeterminacy, and degree of falsity less than 3. So that is the, so for each part it is uncertain. Degree of truth, it is uncertain. Degree of indeterminacy, it is also uncertain. Degree of falsity, it is also uncertain. So we have to define the membership function for each of this, and again same here, we can define these membership functions in any kind of triangular, trapezoidal. So we have triangular neutrosophic fuzzy sets, or trapezoidal neutrosophic fuzzy sets, or any kind of fuzzy sets is here. So we can define different types of neutrosophic environments. So here, so Tn is the maximum degree of truth value, In is the maximum, In and Tn, Fn are minimum value of indeterminacy and falsity here. So this is the graphical representation of any single value neutrosophic set, it is this Tn is truth indeterminacy function, and it is falsity Fn. So this is for green color falsity, and this one is it is for it is for truth, degree of truth, and it is for degree of indeterminacies here. So this is the whole representation of uncertainty of single value neutrophobic set, and we can define this fuzzy numbers in terms of fuzzy numbers as triangular trapezoidal like that. And arithmetic operations for this these type of sets, some multiplications, scalar multiplications, powers, and the score function for any, suppose we are here for any intuitionistic fuzzy sets, so it is defined, score function can be defined as like that: degree of truth 1 minus degree of indeterminacy plus 1 minus degree of falsity divided by 3. So it is average. So here, so that's and in application of these numbers in optimization, basically in multi-objective optimizations and single objective any optimization problem. So we can consider this optimization problem as through this we can consider the parameters, the coefficient parameters, any kind of numbers, either fuzzy numbers, any kind of generalization fuzzy numbers, and through the arithmetic operations we can through the score functions we can convert that into the this. So we are here, so any fuzzy numbers, but we have not considered that generalization here. So we have just or any kind of theory you can apply fuzzy programming or fuzzy linear programming if you consider this linear functions here, graphical representation, this membership functions, and through this we are here to represent that the triangular part of this. So that's this and this one. So it is UK minus LK, and for this UK minus ZXK. So this one is ZXK like that. Similarly here for this part, in the different part of this is UK minus LK, it is divided by this, so ZXK. So it is monotonically decreasing part, this is monotonically increasing part. So that's why combination of this we can define the triangular membership, construction of membership function through this triangularization. And similarly any kind of numbers we can construct, or through this fuzzy linear programming we can use the fuzzy linear programming. It is some simple because it is always less than or equal to 1, so we can consider this less than consider any parameters. It is parameter optimization, it is less than low value of xi between low value and upper value of any. So number constructions, and we can use that. Hyperbolic, it means if we are considering the membership functions, that is hyperbolic type. So that is known as hyperbolic program. Here we can construct this part. This is the 10. This is a membership function for this part, and this is a membership function for this increasing part. So this is hyperbolic 10. Hyperbolic 10. So we can use and we can consider any kind of. Is it okay? Hello?
Yes, please continue.
Okay.
Please continue. There was
So
some.
that's hyperbolic programming we can use to consider any optimization problem. And similarly, fuzzy hyperbolic programming, if we consider that membership function by taking the parameter which is less than lies between 0 to 1, and that membership function also lies between so we are maximizing our membership degree. So that's why we can optimize, we can find the value of decision variables in the, so these are the constants that may be given in the given optimization. So this is a classical optimization through fuzzy set theory. And fuzzy hyperbolic parabolic, if we consider the parabola here, the quadratic part. So that's why quadratic decreasing part, this is the quadratic increasing part which I use to construct the membership function. So through this, if we use these membership functions, then we say it is fuzzy parabolic programming to solve any optimization problem. So fuzzy programming, again we can consider this. It may be non-linear programming, and we solve different methods for using the non-linear programming quadratic to solve this. Using the including this, so basically we are intersecting our decision space through these membership functions. So we have considered that the problem which was considered earlier as the dairy online delivery system of dairy product for fuzzy data, with these are the T1, T2, T3 are the towns, and we are distributing this online delivery in the 8 cities by considering this data, and we can solve this, minimize the delivery time, minimize the transportation loss and transportation the loss of that transportation cost, and maximize the transportation cost of profit of this. So that's we can consider. So it is single objective optimization problem, and we can solve this through these. That is the fuzzy programming, fuzzy hyperbolic, parabolic, fuzzy hyperbolic. So we considered our that's the lower part, lower and minimizing objective functions and maximizing objective functions. So we have decided the goals and construct the membership function through this. These are linear membership functions, and we can consider this by solving this, and we got this result. Similarly, hyperbolic, if we consider the hyperbolic membership, so we get this and solve through this linear programming with the help of software, and that is parabolic consideration we can solve. And here we can use any kind of parameters which may be generalized fuzzy parameters through this. So this is a linear programming, hyperbolic programming solution, and parabolic programming solution. So solution may be some different difference in the solution, minor difference. It depends on the we have considered the type of uncertainty, the type of membership functions used. So that's this was all about this, and one more thing I want to share this year, how to construct it was requested by the by Professor Mukesh, how to construct that score function. So we have
Professor Preetham, your screen is no more visible. Professor Peetam, do you hear me?
हाँ हेलो, इज इट विजिबल? हाँ मैडम, आ गया आवाज?
Yes,
आ
your
आ
voice
रहा है?
we are able to hear, but the screen is not visible. Please share the screen.
मैं ये is it okay where I was?
Not yet. We are not able to see the screen.
Screen is
It's about to come, I think. You please carry on the process.
yes. It is it is okay now?
Not yet. The screen is not visible.
Yes, I am trying to share again. Yes, yeah. It is okay now?
No, the message being displayed is that you have started sharing your screen, but the screen is not visible.
अभी बताना अभी मैं आई एम ट्राइंग
Not visible.
अभी देखिए
Yes, we are able to see the screen.
सो दैट्स मैं हाइपरबोलिक कहाँ था मैं आप जब तक डिस्कनेक्ट हुआ
आप क्विज पर आ गए थे क्विज
न्यूमेरिकल एग्जांपल्स वाज देयर
नहीं इससे पहले था इससे प्रीवियस
so
स्लाइड
hyperbolic so we can construct that
ये वाला
that is the increasing part it was earlier.
Professor Peetam, you are about to tell the construction of score function.
Okay.
Construction of score function.
Score function. So I want to share that it was requested by Professor Mukesh. So that's I want to share one more thing. So we have constructed the membership functions. So it is that is the visible.
Yes, the research paper is visible. Some research.
Yes. It is for research paper. So how to develop that that the ranking function, that is the score function. So it is, suppose we have here, it is the Fermatian triangular fuzzy numbers. It is for membership, it is for non-membership value. So graph, it is the graph of triangular fuzzy numbers, and that is the representation of triangular Fermatian fuzzy numbers. It is A1, A2, A3. It is number for this belongingness, and this is for membership. This is for non-membership. So A1 dash, A2, A3 dash, like that. So A2 is that is, this is common for the both this. So that's why, and always we have considered like that. Otherwise, the on real number line satisfying this inequality, and this is U belongs to 0, 1, V belongs to 0, 1. That is the cubic because of Fermatian. So this, so now this is the construction of numbers. So we have first we have to find the, that is the interval. So for defuzzification, the triangular Fermatian fuzzy numbers appropriately, we can develop that ranking function. So this is suppose this number, and define the expected interval of this number is the crisp interval denoted by this. So EI, EF, we are considering this interval, and defined by it's the lower part of this. So that is the this for membership and non-membership. So this is the representation is here. So here we have, or this is U1, U and V are that is the hesitancy, U hesitancy for this, and the V hesitancy for this. So we are considering this hesitancy for membership, non-membership, V, U and V. So this is the average of that A1, average of that A1 and A2 for this part, left part. We are considering first interval for left part, average of this A1 dash, A2. So because it is defined like that for this part only, and the interval that the integration A1 dash to A2, A1 dash to A2. So we are considering this whole part for this for membership and non-membership, and divided by A2 minus A1 dash, like a construction of any numbers. So that's A1 dash integration. So it is the sum of all values on that real line we are defining here, and divide by that hesitancy also, where we are not considering this A1 dash A2 by 2, and this minus 1 by 2 A1 to A2. तो ये part लिया हमने, that's we are considering this part and this part. So this is the left for left, this is for right. This is for right. So unified. So that is the 1. So we can consider this for whole type of numbers. So this is triangular part, but we can consider this for either is any quadratic functions there, and we can consider trapezoidal type or any Gaussian type or any kind of numbers. We can use triangular, trapezoidal, or this. So we can consider this as for this type of also numbers also. So finally we get this, and the average of ranking function can be defined as average of that interval part. So left part, right part. So value of left part and right part can be this. So by averaging this, we have this component of complete construction of proposed ranking function. So we can construct a new kind of ranking function with the help of what kind of uncertainty you are considering, either triangular, trapezoidal, or exponential, or quadratic, or any kind of. So we get the new kind of functions for different type of functions. So our ranking function is this average of this. So this is average of this comes out to be this. Or when we substituting that is u equal to 1, then we get the that is representing the highest membership value v equal to 1, indicating the highest the lowest non-membership value. So that's it is transformed as new ranking function for any fuzzy number. So this is the score function.
Professor Petam, may I
Yes.
kindly request you to accelerate the entire process because we are running late.
Okay. So that is the thing how to construct the score function. It is okay from my side. Thank you.
Okay. Thank you very much. Thanks very much, Professor Petam. It was a wonderful lecture. I hope all the participants have benefited from this lecture. You have discussed various types of fuzzy numbers along with the fuzzy sets like intuitionistic fuzzy number, and you have also discussed generalization of fuzzy number. Then you talked about triangular intuitionistic fuzzy number and their arithmetic operations, Pythagorean fuzzy sets, and Pythagorean fuzzy numbers. You also compared among intuitionistic fuzzy numbers, Pythagorean fuzzy numbers, Fermatian fuzzy numbers, and the most important thing about the lecture is that you illustrated each and every concept with the help of graph, which made it easy for the participants to understand and grasp whatever you wanted to convey, the whole idea. And at the end, you also discussed the construction of the score function with the help of research paper. I think it was your own research. Thank you so much. Now I invite our research scholar Tajinder to pay the vote of thanks.
On behalf of the organizing committee and everyone attending, I would like to extend our heartfelt thanks to Professor Petam Singh for his thought-provoking presentation on applications of generalized fuzzy sets in optimization. Professor Singh, your discussion on various generalized fuzzy sets as well as the detailed solution methodologies for fuzzy optimization problems provided valuable perspectives that will surely aid the participant in navigating complex optimization tasks. We deeply appreciate your time, effort, and the knowledge you have shared with us. Thank you once again for enriching our workshop with your invaluable insight. Thank you, sir.
Thank you, everyone.
सर एक माई सेल्फ एचएन सिंह.
Any question, please?
हाँ सर, एक मेरा वो था सर, ये जो मेंबरशिप पार्ट वाला ग्राफ था और नॉन मेंबरशिप था, तो ओवरलैपिंग रीजन सिग्निफाई व्हाट, मैं फॉलो नहीं कर पाया.
हाँ, overlapping region that I want. It means I want to share this again.
You can explain. I will get it because the picture is in my mind.
Yes. That's a membership and non-membership. It means that is the overlap.
Professor Petam, we are not able to hear you.
Sorry, I was disconnected.
Yes, please.
So that the membership and non-membership and hesitancy in the data, in our opinion, we somehow the accurate the opinion in favor, opinion in disfavor, and in some points we are hesitate to give the answer.
Right.
So that's why we have considered that uncertainty. And then
Overlapping.
graph is I am considering it here in graph triangular only.
Right, sir.
And for non-membership, so it means the hesitance for if belongingness is higher, then non-belongingness is
Will be lower.
less,
Right, sir.
lower. So that's why it is from one minus something.
Right, sir.
Like that.
Right.
So that's why that graph is like that.
Inverted kind of thing for
Inverted kind of.
Right.
Is it clear to know?
Right, sir.
Now,
Right, sir.
I think it is clear.
Right, sir. Right, sir. Thank you so much, sir. Thank you so much.
Any other participant would like to ask the question? Yes, there is one more question.
Hello. Hello.
Professor Peetam,
Yes, yes.
one more question. A participant want to ask something.
Yes, yes. Please.
Sir, first of all, good morning. Good morning, sir. Sir, my name is
Yes.
Kumar. I am a scholar student. My question is that, sir, if we have any intuitionistic fuzzy set which is normal,
Yeah.
how
Which
can
is normal.
yes, sir. How can we visualize?
So it is simple as like triangular. It means we have the curve like that, normal Gaussian curve, I think, and we have considered, and it is considered in our research paper also that it is.
Professor Peetam, are you with us?
Professor Peetam, are you sharing the screen? Professor Peetam, do you hear me? Professor Peetam, are you sharing the screen? Professor Peetam?
Yes. Just I'm sharing this. Hello.
Yes, sir.
Yes, please. I'm not able to see anything on the screen. No, it's not your screen is visible.
Yes.
Yes, now it is visible. The screen is visible. Your research paper is being shown. Professor Peetam, we are not
Sir, unmute yourself.
able to hear
Sir.
you. Please unmute yourself.
Someone, okay, it is okay.
Yes.
So this is normal kind of curve. This, and we can represent this any kind of curve, any kind of uncertainty. You can consider this here. I think I was able to give the answer.
Thank you, sir.
Hello, who asked the question?
Hello.
Is it okay?
Okay, sir.
Someone asked the question about this, how to
Hello?
represent this curve.
Hello.
Yes.
सर आपकी ना स्क्रीन शेयर नहीं हो रही वो.
Now,
Okay, sir. Is it okay, sir? Thank you, sir.
is it okay?
Yes, yes, Professor Peetam. He's saying it's fine.
Yes, yes. It is the kind of that the number, intuitionistic numbers or any kind of numbers, that is the any intuitionistic we can consider that it depends on that numbers, what type of numbers you are taking. Okay.
Okay. Thank you. Thank you, Professor Peetam. Thanks for handling all the questions. Welcome.
Okay. Thank you, madam. Saru, madam.
Thank you. Thank you very much, Professor Peetam.
May I leave? Thank you all.
Yes.
Saru, madam, and Professor Mukesh sir, and all my teachers who are here.
Thank you, Professor Peetam, for giving such a nice lecture to all the participants. Thanks.
Thank you. I'm leaving now. Thank you so much.
Okay. Now we are about to start the next session, and we have among us Professor Shailendra Bajpai from the Department of Chemical Engineering, NIT Jalandhar. So all the participants are eager to hear you, and now I invite Dr. Rima to welcome the speaker.
Good morning, everyone. Myself, Dr. Rima Singh. I am here to welcome you all from the Organizing Committee, Department of Mathematics, CCH University, Meerut. Now, I am inviting Professor Shailendra Bajpai to deliver a talk on the topic Risk Assessment of Intentional Threats, Application of Fuzzy Logic Concepts. Dr. Bajpai is currently working as professor in the Department of Chemical Engineering at National Institute of Technology, Jalandhar. He is BTech from HBTI Kanpur, MTech from IIT Kanpur, and PhD from NIT Jalandhar. He has authored 6 books and have more than 70 research publications in international as well as national journals of repute and conference proceedings. He is actively involved in the organization of SChemCon 2008, 2012, 2018, and acting as organizing secretary for ChemCon 2024. He has acted as guest editor and reviewer in many international journals. Now, I'm inviting Professor Bajpai. So, sir, please continue. Welcome, sir.
Yeah. Good morning to everyone. Am I audible to all of you?
You are audible, sir.
So I'll share my slide before I start. Yes, that's visible to you. Is my slide visible to you?
Yes, it is visible.
Okay, fine.
So
thank
kindly,
you.
kindly make it full screen.
Yeah, I'll do that. Yeah, is it okay?
No, it is not at full screen. यहाँ से? No.
I think it's full screen. Is it okay now? Yeah, is my
Yes, sir.
screen?
Visible,
Yes,
sir.
sir.
Yes, now it is
It's
fine.
okay. Yes, sir.
It is fine now. You can proceed.
At the outset, I would like to thank Professor Mukesh Sharma and Murtaza for inviting me to the international workshop on cutting edge innovation in soft computing, communication, and artificial intelligence, an international symposium being held in Merit University, and making me the part of this August gathering. I've been already introduced, and although I'm not from core mathematics background, as you know that, but I do work in chemical engineering, risk assessment, membrane separation process, chemical process safety, and we use mathematics a lot. So I have a lot of ideas, and I would like to discuss some of them. And if we join hands, like chemical engineers and computer science engineers and mathematicians, if we join hands, so we can solve many problems. So one of the problems that we are facing is risk assessment of intentional threats. And in my talk today, I'll be talking about one of the way of solving problem of security risk assessment using fuzzy logic. But there are many ways by which we can do it, and I'll discuss the basic idea of risk assessment of intentional threats, and what are the do's and don'ts, and what are the future current challenges. So we'll discuss. I'll try to keep my talk for only like 35 to 40 minutes because I have another meeting by 11:35. So I'll wind it up by 11:25 or so, and so that we can have quick 5-minute question and answer, and then I can wind it up by 11:30. So I'll be a little fast, but because I was available till 10:30, but somehow it got delayed, and because I have ongoing things, so please bear with me. Uh, Before I go to the topic, I would like to talk something about my institute, that is NIT Jalandhar. Its NIRF ranking is 48th in NIRF 23, and now it is 56. It's a renowned institute, one of the institute of national importance. We all know that. We get very good students from the BTech stream. We also have MTech, MBA, masters in various disciplines. You can see here. About chemical engineering, we have 17 faculty, and out of that, we have 5 professors, 4 associate professors, 8 assistant professor, a number of research scholars, a number of staffs. We have all cutting edge chemical engineering laboratory, all important equipment we have. We are very active department, and not only with the academics, we do a lot of extracurricular also. We organized many conferences, and one of the most important conferences you would have heard about the Indian Institute of Chemical Engineers. We call it IICHE ChemCon. So we are the only NIT who have done it twice. So we did it in 2012. We have done it in 2018. And I invite all of you, because we are again going to organize ChemCon, IICG ChemCon 2024 in December 2024. That is 27th to 30th of December. So it will be a big conference where we are expecting around 1,000 people, and there would be Indo-Canadian, Indo-Japanese, and Indo-US symposiums also. So many people from across the world are expected. So I take this forum as an opportunity to invite you all, because I am an organizing secretary and one of the council member of IICHE. This is my scopes profile. If you find anything interesting in my talk, you can just go through it. This is my Google Scholar profile. Now, in order to understand the risk assessment of intentional threat, it is very important to understand the concept of safety and loss prevention, uh, and the difference between hazard and risk. So these are very general things, because our whole concept of security risk is dependent on these definitions. So I want you to just quickly go through this. There is a lot of difficulty in understanding the difference between hazard and risk. So you can say a hazard is a chemical or physical condition that has the potential to cause damage to the people, property, or the environment, as you can find it. And risk is a measure of human injury. So risk has always two components. Basically, it has the failure statistics, so probability of failure and the severity. So considering these two aspects, we can measure the human injury and the damage or the loss. That is what we call risk. So that is the basic difference between risk and hazard. And safety for a loss prevention program is a detailed study by which we try to minimize the or eliminate the hazard before it actually occurs. So this is an important slide. I'll take a couple of minutes. Uh, if we talk about what could go wrong to a chemical process industry, when I say chemical process industry, I mean chemical process facilities. So all processing plants, all warehouses, all distribution, all transportation, all other associated facilities are also involved. So that is a part of it. So it has two things that can happen to a chemical process facilities, any component of chemical process facility. One is unintentional threats, and unintentional threats can be due to natural calamities or accidents or technical malfunctioning or human error or things like that. And whereas intentional threats are concerned, the human aspect is there. Intentional means somebody is intentionally trying to harm the system, right? So it could be due to sabotage by a disgruntled employee, or maybe by a terrorist activity, or maybe a violent protest by the employees, or so intentional threats that could lead to similar consequences as we get from the accidents or unintentional threats. Uh, One of the things that can come to your mind is why this is an important thing, because chemical process industry or facilities, they are high targets in the eyes of the adversaries, and because of their extreme importance to any country, and they work in extreme operating conditions, and any kind of disruption will badly hurt the economy. I give you one example. There was a major fire in Jaipur, IOCL Jaipur distribution plant, and once there was a fire, major fire, the whole highway was closed for 48 hours. Although it was not an act of intentional threats, but it was an unintentional activity. But the consequence in both the cases will remain same. So the whole highway, Delhi Jaipur highway, was closed for more than 3 to 4 working days. So that has a lot of costs. So disruptions will badly hurt the economy, and also there is a potential loss of mass casualties. The example is what we have seen in Bhopal gas tragedy. We have seen that the methyl isocyanate was released, and then it went to the offsite shanty towns, and then what havoc it has done. Thousands of people got killed, and uh, we know that Union Carbide plant was shut, and now it is being taken over by Dow, and we all know what are the consequences involved. Again, it was not an act of sabotage. Although at that point of time, the Union Carbide said that somebody intentionally put water and chloroform into the MIC tanks, so that caused the runaway reaction, and an MIC was released, and that is the main reason, according to the West. If you read West books and journals, you will see this narrative, which is absolutely bogus and wrong. But had it been an intentional act, so we know that there is a potential for mass casualties. So these are some of the examples that I wanted to share. There have been a lot of security incidents that have happened to make this thing more credible. There have been a sarin attack on Tokyo subway in 1995. There have been many oil pipeline sabotage. Many of them, most of them, are not reported in India. Some of them are reported in Assam by determined adversaries. In 1998, in Nigeria, people tried to steal the oil from the oil pipeline, which caused the explosion and killing 1,000 people. Many such incidents have happened in Africa. A disgruntled employee intentionally created a cyber attack on wastewater treatment in Queensland, Australia. So there have been many such events. Some of them are reported, some of them goes not reported. So I don't want to get into that, but we have many of such incidents we have thoroughly investigated, and we find it that it is extremely important to address this. So these are some of the quantification. I don't want to get into each slide. Now, what can be done? What should be a part of risk assessment of intentional threats? There are three components basically as the time progress, and there have been. Now, today is the 12th of September 2024, and the idea of risk assessment of intentional threats got major importance after 9/11 attack. We all know that yesterday was 11 September. That is a day when we have seen that what has happened in USA, where Twin Tower was attacked by determined adversaries using the jetliners. So what we have seen that even the aircrafts, if hijacked, they can be used as a weapon of mass destructions, and we have seen what kind of havoc it has done. So 2001 and 2024, it's almost 23 years. So a lot of research has taken place in 23 years, and I started this research in 2003. So almost 21 years of my research into this field, which is very close to me. So it has three components. We will understand the SPAs, then we will digress from this, but just to make things easy for you, for people from non-security background, it's important for you to understand these things. So threat analysis is all about, like in process hazard analysis, we talk about knowing hazards. So similarly, in security risk assessment, we try to understand the threat analysis, right? What are the things that would cause the threat? And then there is a vulnerability analysis where we try to find out the scenarios. Uh, Maybe we will brainstorm a group of people set as we do it in BHA. And we will try to brainstorm and we'll try to find out what are the scenarios, credible scenarios. So if we have 4 or 5 scenarios, then we can prioritize those 4 or 5 scenarios, and we'll see to the more risky or more credible scenarios. So vulnerability analysis will tell us how to do that. And there is a security risk factor table. This is a pre-screening tool that allows us to find out what is the current security risk status of a given facility. So threat analysis, we try to, as I said, as we do it in hazard analysis. So we see, what could be the uh, sources of threats, types of threats, intentions and motivations of adversaries, likelihood and severity of threats. When we actually perform security vulnerability assessment, so it is a very detailed exercise. So I am just giving you and surfing through these slides so that you can get a good idea. It is important to understand the threats could not only be an external one, so it is not with the perspective of only terrorism. So it has two components basically, internal threats and external threats. So I take internal threats more seriously because when insider does create a problem, then it is a big problem. So any disgruntled employee or disgruntled employee working in collision with some determined adversaries like terrorists, then this becomes very, very important. You would have seen recently in the last 1 month, there have been a lot of activities in railway tracks in India, especially around Kanpur. So we have found cement girders and iron material, and people are trying to intentionally create the derailing of the passenger trains. So it is a very dangerous activity, and that is what. So we have to do in order to understand the risk assessment of intentional threats. We have to understand the mindset of the people who are involved. So there is a very strong possibility that there would be a single person maybe working in a lone wolf attack style. So as a law enforcement agency, or the people working in security, or people like us working for security, so we should be one step ahead of these determined adversaries to defeat them, to defeat their dangerous designs. So this is external threats. We know what would be our sources. So these are internal and external. We can understand what they can do to chemical process industries. But now This is something which we have done it a few years back. But now I think it's not only to chemical process industries, because I am a chemical engineer, so my main target was to protect oil and gas installation, refineries, and fertilizer plants, and any such type of things. But now I think any critical infrastructure, including our railway track, is our priority, and I intend to work on that because this is something that has come in just 1 year that people are trying to intentionally derail the train. So what are the things, what best we can do with whatever information we have? So we have to use it for the benefit of the country as a citizen. It is our duty also. So these are the potential threats to CPI. What can go wrong? We all know that, sort of self-explanatory. So these are the scope of what could go wrong. These could be the intention and motivation of industries. Many people they focus their research on these aspects. So I don't work on this. So I'm just reading it out. As I said, the risk has two components. It has a component of severity and there is a component of probability in safety risk. We have severity and like probability of failure. In case of security, this probability is replaced by likelihood because there is no guarantee. I mean, there is no statistical data that, and there is no redundancy of statistical data in security. That if we have a data that security incident has happened 5 times in a year, so there is no guarantee that for the next year it will happen 5 times a year. It may increase, it may decrease. So that is why we call it likelihood. So this is a risk assessment matrix. If you have a high likelihood and high severity, you will get very high risk. So it's like low, very low risk. In security, there is an important term called target attractiveness factor. So if you try to use mathematics, you have to understand this concept. I'll give you one example where we have used this concept using fuzzy logic. And if you use your expertise in this topic, many publication you can make. And if you understand this topic, it's a very useful topic and has a lot of publication potential. And not many people are working on it. Like in India, I don't find many people are working. We have people from Pondicherry University and IIT Bombay and IIT Chennai and myself at NIT Jalandhar. I don't find many people who are working in the field of security and safety. So target attractiveness factors like location of facility, visibility, ownership, importance of product. Now, you should ask me why location is important because location of a plant makes target attractiveness in the eyes of an adversary. Like if something is located on the highway, then obviously it is at a higher risk, and to in comparison to a place where something is being located in a remote village. Similarly, visibility also is visible from train tracks or from road, then it is more attractive. And if it is not remotely located, not visible, so all these things are important. So we have to understand these things. Then severity of attack is dependent on how much inventory you have of flammable and toxic materials. Whether you have what kind of toxic materials you have, what kind of flammable material you have. Do you have any matter of concern which can be used as a precursor to a weapon of mass destruction? For example, in many places ammonia is being used to make drugs, methamphetamines drugs. So many cases have been reported where these ammonia from refrigeration or ice making factories they have been stolen there. And in that case, many times the thieves are being exposed and they have to be rescued. So these kind of things, the presence of hazardous chemical and the impact on surrounding community. So all these will have an impact as far as severity of attack is concerned. The third thing is the ease of attack. That is how prepared you are, or a chemical facility or critical infrastructure. For example, in our train tracks, which are lakhs of kilometer and totally unguarded most of the places. Now, in these places, our ease of attack is very easy. Anybody putting even a folding bed onto the track, how you are going to stop it. It's very so anybody can put anything like to derail the track, right? So we have to understand, maybe they can place a car or an old car. So we have to understand the ease of attack and what are the things, what are the scenarios, what are the vulnerabilities that can come on hand. The vulnerability analysis is something like assessing weakness that adversaries can exploit or identifying ways the credible threats could be realized. These are the normal steps in vulnerability analysis, very similar to what we do in process design analysis. So those from safety background will understand. This is a typical vulnerability assessment worksheet, which is very similar to what we do in safety, like in HAZOP. So this was done in 2003 by our team, and we have shown that how HAZOP can be implemented, and we have made sample vulnerability assessment worksheet for chemical process industries, and this was published in Journal of Loss Prevention in 2004, one of our pioneer paper in security. Then we thought of identifying a screening tool. So what could go wrong? How to find we can't do detailed SBA for all the process facilities. So the idea is security respective. So what we did, we made various parameters. We took different parameters like location, visibility, inventory. You can see that, which is all these risk factors have emerged from target attractiveness factor. You would have seen that ease of attack, severity, and likelihood. So all those have been contributed to the risk factors. So there are 15 risk factors, and depending upon them, if your total score for this comes below less than 15, so it is a low risk. If it is greater than 45, it is an extreme risk. So we have to initiate further detailed risk reduction measures. So what are the security countermeasures? That is based on the topic called detect, delay, respond, and mitigate. I will not talk about that. That is not the scope in today's presentation. Just you can see that what are the things that one can do to make things work for risk assessment of intentional threats. This is an interesting slide where we talk about the trade-offs between safety and security. We should understand the difference between safety and security. Many times, all the tools that we have in safety will work for the security, and many times there would be trade-off also. Like in safety, we have layers of protection analysis, whereas in security we have rings of protection analysis. So in security, we provide rings, we provide layers of protection, and in safety also we have different barriers, safety barriers, so that something untoward should not happen. So in safety we have probability, in security we have likelihood. In security we have attractiveness. This is important. So we have to do something to minimize the attractiveness and vulnerability of a chemical to prevent security incident. Many people post 2006 have worked, so the references have been given. There is a CCPS and API 780. I will show you these SVA techniques, which we call security vulnerability assessment techniques. So they have their own ways of looking at a problem, and API, which is